Good morning, everybody. Today I will discuss multiple correlation coefficient. That notation is R. Now, R1.23 square is the correlation coefficient between x1. Its estimated value is given by the plane of regression equation of x1 on x2 and x3, or show that with usual notations r1.23 square is equal to r12 square plus r13 square minus 2 times r12 r13 r23 divided by 1 minus r23 square. The solution of this problem, we know that the estimated value is E1.23 is equal to B12.3 x2 minus B1.32 x3. Therefore, x1.23 is equal to x1 minus B123 B1.23 into x2 minus B13.2 x3. That equal to x1 minus, we know that E1.23 is equal to that value. Substitute that that value, that is x1 minus E1.23. This implies E1.23 is equal to x1 minus x1.23. Since xi's are measured from their respective means, therefore expectation of x1 is equal to expectation of x2 is equal to expectation of x3 is equal to 0. Now find out expectation of x1.23 is equal to expectation into bracket x1.23 is nothing but x1 minus E1.23, that equal to take expectation inside expectation of x1 minus expectation of E1.23, that is equal to 0, and also expectation of E1.23 is equal to 0. Now R1.23 is equal to covariance of x1 x1.23 divided by square root of variance of x1 into variance of x1 E1.23, that is equation number 1. We know that covariance of x1 E1.23 is equal to expectation of into bracket x1 minus expectation of x1 into bracket E1.23 minus expectation of E1.23. We know that expectation of covariance of xy is equal to expectation into bracket x minus expectation of x into y minus expectation of y. Similarly, this value. Take expectation inside expectation of x1 into E1.23, that equal to expectation of x1 into E1.23, that is equal to expectation into bracket x1 into E1 x1 minus x1.23, that is the value of E1.23. This is equal to sigma 1 square minus E1.23 square, that is equation number 2. Similarly, variance of x1 is equal to sigma 1 square, that is equation number 3. Variance of E1.23 is equal to expectation into bracket E1.23 minus expectation into E1.23 whole bracket square, that equal to expectation into bracket E1.23 square. This is equal to expectation into bracket x1 minus x1.23, that bracket square. This is equal to expectation into bracket using the a minus b whole square formula, x1 square plus x1.23 square minus 2 into x1 x1.23. This is equal to take expectation inside the bracket expectation of x1 square plus expectation of x1.23 square minus 2 times expectation of x1 into expectation of x1.23. This is equal to sigma 1 square plus sigma 1.23 square minus 2 times sigma 1.23 square. Therefore, variance of E1.23 is equal to sigma 1 square minus sigma 1.23 square, that is equation number 4. Now, these values substitute in equations 2, 3 and 4. In equation 1, we get R1.23 equal to sigma 1 square minus sigma 1.23 square divided by sigma 1 square into x sigma 1 square minus sigma 1.23 square. Now, squaring on both sides, R1.23 square is equal to sigma 1 square minus sigma 1.23 square, that bracket square, Now R1.23 square is equal to sigma 1 square minus sigma 1.23 square is cancelled divided by sigma 1 square, that equal to sigma square root of sigma 1 square minus sigma 1.23 square divided by sigma 1, that equal to sigma 1 square upon sigma 1 square minus sigma 1.23 square divided by sigma 1 square. Sigma 1 square cancelled, that is 1 minus sigma 1.23 square root by sigma 1 square. Now taking minus sigma 1.23 square root by sigma 1 square, take LHS side, that is R1.23 plus sigma 1.23 square root by sigma 1 square equal to 1. Sigma 1.23 squared by sigma 1 square equal to 1 minus R1.23 square. This becomes 1 upon sigma 1 square into sigma 1 square upon omega 1 into omega equal to 1 minus R1.23 square. Already proved this omega divided by omega 1. Therefore, sigma 1 square cancelled. Omega divided by omega 1 is equal to 1 minus R1.23 square. Therefore, R1.23 square is equal to 1 minus, takes the omega upon omega 1 RH side, that is minus omega divided by omega 1. That equal to 1 minus, what is omega upon omega 1? 1 minus R12 square minus R13 square minus R23 square plus 2 into R12, R13, R23 divided by 1 minus R23 square. That equal to 1, take minus inside the bracket, minus R23 square minus 1 plus R12 square and so on. That divided by 1 minus R23 square. That simplification, R12 square plus R13 square minus 2 times R12, R13, R23 divided by 1 minus R23 square. Therefore, R1.23 square is equal to R12 square plus R13 square minus 2 times into R12, R13, R23 divided by 1 minus R23 square, which is the required multiple correlation coefficient between x1 and x2 and x3. Similarly, multiple correlation coefficient of x2 on x1, x3. We know that E1.23 is equal to B21 0.3 x1 plus B23 0.1 x3. Therefore, x2.13 equal to x2 minus B21 0.3 x1 plus B23 0.1 x3. Therefore, x2.13 is equal to x2 minus B2.13 into x1 minus take minus inside, that is minus B23.1 x3. Therefore, x2.13 equal to x2 minus E1.23. Therefore, expectation of x2 is equal to 0 and expectation of E2.13 is equal to 0. Therefore, R2.13 is equal to covariance of x2 E2.13 divided by square root of variance of x2 into variance of E2.13, that is equation number 1. We know that covariance of x2 into E2.13 is equal to expectation of x1, expectation of x2, that is this small correction, x2 into minus expectation of x2 into bracket E2.13 minus expectation of E2.13. Now, using R2.13 equal to sigma 2 square minus sigma 2.13 square divided by square root of sigma 2 square into sigma 2 square minus sigma 2.13 square. Now, squaring on both sides, R2.13 square is equal to sigma 2 square minus sigma 2.13 square, that bracket square, divided by sigma 2 square into bracket sigma 2 square minus sigma 2.13 square. Sigma 2 square minus sigma 2.13 square cancelled. Only sigma 2 square minus sigma 2.13 square divided by sigma 2 square, that equal to, now that equal to square root of r2.13 square root of sigma 2 square minus sigma 2.13 square divided by sigma 2. This is equal to squaring on both sides 1 minus r2.13 square divided by sigma 2 square, because sigma 2 square cancelled. r2.13 plus sigma 2.13 square by sigma 2 square is equal to 1. On simplification, r2.13 square is equal to r12 square plus r23 square minus 2 times r12, r13, r23 divided by 1 minus r13 square, which is the required multiple correlation coefficient of x2 on x1 and x3. Thank you.